In this video, we're going to look at a worded problem, which is going to look at modelling using series. Now, the question and the problem says Bruce starts a new company. In year 1, his profits will be $20,000. He predicts his profits to increase by £5,000 each year. So in years 2, his profits will be £25,000, and so on to year 3, £30,000. He predicts this will continue until he reaches annual profits of £100,000. He then models his annual profits to remain at £100,000. Part A says calculate the profits for Bruce's business in the first 20 years. So we'll deal with part A and we'll look at the other part shortly. So let's have a look at what he's saying about his profits. He's saying that at year 1, he's going to have a profit of £20,000. Come year 2, he's going to have a profit of £25,000. At year 3, he's going to have a profit of £30,000, and so on. Now, hopefully you'll be able to see with this that what it's actually forming is a sequence, and specifically, if we're going up by £5,000 each time, then we've got a arithmetic sequence. So his model looks at going up in profit until he reaches a profit of £100,000. What it doesn't tell us is how many years that's going to take, which is actually what we need to find out first. So in order to do this then, let's list out what information we know about our sequence. Well, we know the first term, A, his profit in his first year is £20,000. We can also say what the common difference is, because each time, as it tells us in the question, he's going up by £5,000. So our common difference must be £5,000. But actually, if we're looking for the year that it reaches £100,000, his profit, what that is giving us is the profit in the nth year. So we can say that UN, the nth term, is equal to 100,000. And from that then, well, we have a formula for the nth term of an arithmetic sequence, such that UN is equal to A plus n minus 1 times D. Well, we can use that formula with our values there and actually find out the amount of years that it's going to take to reach up to a value of £100,000. So if we substitute in, we have 100,000 is equal to A, which is 20,000, plus n minus 1 times D, which is 5,000. A little bit of rearrangement, subtract the 20,000, so you have 80,000 is equal to 5,000 times n minus 1. Divide by the 5,000 and you've got 16 is equal to n minus 1. So n must be equal to 17. So in other words, it's going to take 17 years to reach a profit of 100,000. So it's at this stage that we're going to say, right, well, if he's making this profit each time, so he's making 20,000, 25,000, and we want to work out the profits for his business in his first 20 years, so we want to work out the total profit that he makes. In other words, we're going to have to add up each of these profits. So to find his total profit, we need to find the sum of the first 17 years, but actually we want to find it up to the first 20 years, so there's an additional 3 years there. So we need to add on 3 lots of what his profit remains at, which is 100,000. Well, fortunately, we also have a formula for the sum of the first n terms of an arithmetic sequence, such that Sn is equal to n over 2 times 2a plus m minus 1 times d, which we can substitute in for S17. So we've got 17 over 2 is times 2 times 20,000 plus 17 minus 1, which is 16 times d, which is 5,000. 40,000 plus 80,000 is 120,000, divided by 2 is 60,000, so you have 17 times 60,000, which gets you a value of 1,020,000. So, therefore, total profits in 20 years is equal to, if we substitute in that value, 1,020,000 plus our 3 lots of 100,000, which is 300,000. That gets you 1,320,000, and that's our value for part A. Moving on to part B then, it says state one reason why this may not be a suitable model. Well, in this model, Bruce is assuming that his profit is going to increase by the same amount each time. That seems quite unlikely, and that's all that you really have to state. That it is unlikely his profit will increase by the same amounts each year. Okay, so it's as simple as that. That would just be a 1 mark question, but it gets you to see if you can understand what's happening with the model. So they quite like having those in the modelling question. Moving on to part C then, it says Bruce's financial advisor says that the yearly profits are likely to increase by 5% per annum instead of what Bruce's model is. And it says using this model, calculate the profits for Bruce's business in the first 20 years. So let's have a look at what this means. If we're increasing by 5% each time, it means that from our first value, the next value is going to add on 5%, and then it's going to go up by 5% again and again each time. Well, if we look at this then, what we can say is that if we're starting at 100% and we increase by 5%, we are adding on 5%, that gets us 105%, or, as a decimal, 1.05. And actually, this becomes a multiplier, because you take the original amount, you multiply it by this, it gets you the new value. You take that amount, multiply it by this, it gets you the new value, and so on. If this is our multiplier, really, this is going to be an R value, because what this is forming is a geometric progression. Now, because again we want to find the total profits over 20 years, it has to be another summation. But this time, because it is for a geometric series, the formula is slightly different. We have the sum of the first n terms of a geometric series is equal to a times 1 minus r to the n over 1 minus r. So the 5% model gives us what the r value is, what that multiplier is, and actually in both problems we have a starting value, an a value for the first term of 20,000. Now, because we're looking for the first 20 years, the problem is also giving us an n value, so that is equal to 20. And at this stage, all we need to do is substitute in those values. So the sum of the first 20 years gets us 20,000 times 1 minus r, which is 1.05, to the power of n, which is 20, over 1 minus 1.05. Putting this into your calculator, 1 minus 1.05 gets you minus 0.05. 20,000 divided by minus 0.05 gets you minus 400,000, but slight rearrangement is we can say 400,000 times 1.05 to the 20 minus 1, taking into account the minus there, Put that into your calculator and you end up with 661,319.08, and this is in pounds. You actually get 0.0821, but because this is currency, you stop at 2 decimal places there. And that would be true for all currencies, unless it tells you to round to the nearest pound or dollar, depending on the question. But this value is in contrast to the profits in Part A. And you can see if it's an arithmetic sequence, as Bruce originally predicts, his profits over 20 years are going to be a lot greater than what his financial advisor predicts on a geometric sequence and series, where the profits are around half that as predicted by Bruce.